Good morning, mathematicians. We're back. Time to do some math. Maybe we'll return to graph theory, but maybe we should spend some time reviewing, looking at archives, seeing what new papers might have appeared. Yeah, I don't know. I don't know. What do you think we should do? Let me know in the comments. Um, Yo, owners effects. Yo, yo, yo. Yo, yo, yo. I've been thinking about office hours lately. Maybe I need to rethink them. I like doing them, but I also wonder, do I spend too much time doing them? Should I? I mean, you morning attendees will probably say no to this, but should I try doing nighttime office hours for a while instead? Or should, the other thing I've been thinking, you met Hong Mong today who proved the Kakaya conjecture. That's cool. Were they giving a talk or something at your institution? Good morning, Arad. Yeah, the other thing, I've been thinking of is like if instead of spending an hour live streaming every morning, I think I've said this before, but what if I spent an hour like teaching myself Manam instead? Oh, hi, Mom. Good morning. Love you. What if I spent, that time teaching myself Manam so I could make like better quality YouTube videos and then just, be a professional math YouTuber? Could be an idea. Hello, Kostaka Corey. I mean, there's a part of me that does think, oh, maybe I could do Manam learning live streams, but we all know how efficiently I learn on live streams. So, I don't know. Just ideas, just floating around ideas here. Anyways, what's happening? On archive? Hasn't been a ton of new stuff here. I don't know. Group theory? Wait, finite groups? Yeah, let's look at finite groups. What's happening in finite groups? Last time we looked here, there was some crazy stuff. You have a linear algebra exam tomorrow. Well, good to see that you're studying hard by listening to me yap in live stream. Hopefully, you've at least got a book open, a book open, and you're studying while you listen to me yap. Analog of Galois theory for arbitrary finite field extensions? What? Isn't that just Galois theory? I don't understand. Yeah. CELO subgroups and the number of irreducible characters. Ooh, of degrees divisible by prime. Ooh, that looks cool. We were just asking about CELO theorem analogs of representation theory, so that seems cool. That seems very cool. Permutation characters of finite group. I am interested in that. Yeah, I should really, I should be applying to postdocs doing representations of finite groups. Clearly, I find it interesting. You're almost done. You need to solve problems from Horn and Johnson. I've never looked at that book, but one is never done. One can never be prepared enough. There's no end to how prepared one can be. Okay, let's try and figure out what the hell is going on in this paper. Is a finishing touch to classical Galois theory of arbitrary finite field extensions? I don't understand. I mean, we completely understand finite field extensions, do we not? What is there to say? What is a one manifold? It's just a one-dimensional manifold? Yes, it is. Yeah. The classical Galois theory covers the case of finite Galois field extensions. Okay. For finite Galois field extensions, the objects are their Galois groups and their invariants. Okay. In 2, we introduce a new ring theoretic approach to Galois theory, which is based on the principle of maximal symmetry. In 3, the maximal symmetry of a normal finite field extensions yields an analog of Galois theory for them. So we should go and read these other papers first, I guess. The aim of this paper is to obtain an analog. Okay. I mean, maybe the map. What is this? What's going on here? The map from, I guess, subfields, this is supposed to mean, and this is supposed to mean subgroups. Sends this to this. Finite purely inseparable extensions have trivial automorphism group but rich subfield structure. Finite purely inseparable extensions have trivial automorphism group. Finite purely inseparable extensions. I should not have to Google this term, but here we go. K-algebra, they're poking me, yeah. Yeah, how can it not have any automorphism? What? Purely inseparable finite purely have trivial automorphism group? What? No, this can't be true. An extension characteristic P such that all elements is a root of that. Purely inseparable extensions, sometimes radical extensions. Okay. 7 equivalent things. Equivalent characterization. Nothing about Galois. Like, surely the Galois group is not trivial. It's just not, because the automorphism group is not trivial, because I mean, it doesn't matter. It's a finite field. It's a finite field. So unless this person is saying that the only finite periable Leo, the you keep getting confused. The cute funny one is here, is the one hosting the stream. Clearly you're turned around. Well, we're reviewing some papers. We're looking at some papers, but I mean, unless Q is equal to P, this has non-trivial automorphisms. So, am I just what am I misunderstanding? They're normal extensions, but normal field extensions are a larger class. Okay. For a long time, it was an open problem to produce a Galois theory for normal finite field extensions. It was? What? Gang, am I out of my mind here? Is this true? What is this person talking about? Am I out of my mind? Or are they? Jacobson introduced an analog of Galois theory for purely inseparable field extensions of exponent 1. Where the Galois groups, which are trivial, really are replaced by restricted Lie algebras of derivations. Finite dimensional extensions. Yes, I mean they're talking about finite extensions. What? What? Galois theory of purely inseparable extensions. Galois is separable and normal. Yeah. Separability is automatic. And characteristic 0, so there may not be as many familiar examples. When did I do my bachelor's? I graduated in 2019. Okay, let's see. What does AI say? Automorphism group fails for purely inseparable extensions because the only automorphism is often the identity. Yeah, but this can't be true for finite fields, right? This is not the case for finite fields. Am I crazy? Purely inseparable extension occurs exclusively in fields of positive characteristic. Sure. The key issue is that all roots of this polynomial are identical in an algebraic closure. Oh, specifically, they're all alpha. So there are no non-trivial automorphisms that fix the base field and move the elements of K. Okay. Was 2019 such a good year? I guess so. Yeah, I guess it was. No, this paper explicitly says... Wait, Let's go back to the abstract. Of finite field extensions. Oh, okay. They mean... Right, I see. They just mean finite extensions. It's just I was thrown off by finite field extension. No. Right. Okay, I see. But I'm a little thrown. Why are they K is a field. Okay, just some field. K bar is its algebraic closure. Yeah, they're just talking about finite extensions. Hello, Russ. Hope you're doing well. Hope your studies have been going well. I see. Okay, confusion has been observed. Wait a second, but oh, okay. Here, K is I guess a function field. I see. That makes sense. Okay. All right, I'm on board now. Right, so here's some function field, and then they're adjoining other things. Okay. I'm surprised then that there was that this was left undone, but then I guess it's cool that this person's finishing this thing, this train of thought. Right. Okay. Interesting. I'm more excited to go on. To the other papers. TBH. Now that I got a handle on what this person was doing. But it does seem interesting. Uh, here is some stuff that I'm intrigued in. So yeah, CELO subgroups and number of irreducible characters and permutation characters of finite group. Okay, so let's take a look at this one. What is that person doing? They were basically, I guess, I think they said they were essentially completing the development of Galois theory for completely inseparable extensions. I think that's what they said they were doing, which I guess had not been carried out yet. And there's something to do with rings instead of groups. I wasn't quite sure. Okay, let G be a finite group, P a prime. We establish an upper bound for the derived length of a CELO P subgroup in terms of the number of irreducible characters whose degrees are divisible by P. Cool. We also prove that if B is a P block of finite P solvable group G with defect group D, then the derived length of D is at most one more than the number of ordinary irreducible characters of positive height in B. Crazy. My degree is divisible by P. This is true. Because my degree is huge. Yeah. So let G be a finite group and P a prime. The Ito, wait, is that the same as the Ito integral guy? No way. No way. No shot. This asserts that P divides the degrees. The Ito-Michler theorem asserts that P divides the degrees of no irreducible complex characters. Okay, wait. So P does not divide. They're saying that P doesn't divide the degree of any irreducible complex characters of G if and only if G possesses a normal abelian CELO P subgroup. Or I guess the other way to say it then would be that P divides the degree of a complex irreducible character if and only if G does not possess a normal abelian CELO P subgroup. Okay. Sure. That seems cool. I want to learn more about that. Fix a CELO P subgroup P of G and let NG denote the number of complex irreducible characters whose degrees are divisible by P. We refer to such characters as P singular characters and their P singular character degrees. Number of complex irreducible divisible by P, right. And CD for the set of their degrees. From Ito-Michler, if this is 0, then the derived length of P equals 1. In particular, in this case, we have this. For finite group satisfying this, we're completely classified by Guralnik et al. For such a group, we have this. And then these people proved in 20 that for all such groups, I like, I kind of wish they had used the citation style. What else is CD? CD is usually used for something, CD's nuts, yeah. Cohomological degree. I think there's no chance of confusion here, though. But, I wish they used the citation style that tells you the beginning of the author's names and the dates. Like, I feel... Because, I have no idea, right now. I mean, I can go check, but it's just like I would like to know, like, was this done 100 years ago or was this done earlier this year? You know what I mean? Okay, cool. Therefore, if the above conjecture holds, in 10, the author verified this for symmetric groups, finite, general, linear, unitary groups, and also proved the following question. Yeah, I wonder who's the professor out of these people. Which one's the professor, I wonder. So I want to how do I break into this area? I guess I just start reading these papers and trying to prove things. Yeah, how do I maybe I'll just Google these people and see which one's the prof. Um, who's maybe they're all profs. I don't know. But the stuff seems cool, and I could see myself pivoting to this area. So let me do a little digging. Let me do a little digging and see if anyone wants a Langlands boy to help them on their team. Who needs a Langlands boy? Everyone needs a Langlands boy. We never double up terms in math. Yeah. The author is called One, and they published it in year 6. I think so. I mean, this is cool. I like this, to be honest. I like this. I can understand it. I feel like, okay, I haven't gotten into the details of proof yet, but like, I don't know. This seems really cool to me. I mean, the Langlands is really cool, and I don't know. I'm cool and fancy, but it feels like it's too fancy for me. Part of me feels like opening up a book on infinity categories and just saying, you know what, screw it, I'm gonna go for it. But honestly, I don't know. I feel like this is more my speed. I feel like this is more stuff. Like I feel like I really get it, and I have a handle on it, and yeah, it's more tactile. I feel like I can really write down examples. Um, you know, I feel like I could compute stuff. I like making tables like this. I don't know. This is I don't know. It's definitely of interest to me. So, but let's see. So this guy's a prof. My research page is up. Okay. If you're looking for an Australian guy who does finite group theory, no relation, you're in the wrong place. Wait, what? Oh. Oh, interesting. Who does finite group theory? So this is not the person I'm looking for? Okay. That's funny because I also was emailing Victor Ginsburg of Chris and Ginsburg fame. It was one of the main books I had to study for my PhD, and I ended up emailing the wrong Victor Ginsburg, apparently. So, um, University of Akron, maybe that's the guy. No, wait, that's the one I was just at. James Christ. But okay, so it seems though like this guy. It seems like this guy is a prof. So maybe I should email him and reach out to him and be like, hey, how do I? Oh yeah, Akron. Maybe if I add that to. Wait a second, but now I'm confused because this says University of Akron. This email says University of Akron, and he says I'm not the guy that does finite groups. Um, but this is clearly a paper about finite groups, about representations of finite groups. Let's look at his research page. I'm so confused. This is all about finite groups. What is going on? What is uh, uh, what is going on? This is literally all finite group stuff. Is it a joke? Is he making a joke? I don't know. I don't know. Uh, I'm gonna message this guy though. This guy does not want emails. Well, I'm gonna email him anyways. I might. Well, let's go peep in on the other guys. Mark Lewis, also prof. Yeah, much of my research regards. Cool. Yeah, maybe I'll email him. Well, I'll try and figure out who seems like the friendliest dude to contact. This dude seems pretty friendly, I guess. Yeah. Have I tried Typist or Tips? I don't know how to say it. Yeah. No, I haven't, and I can't imagine really why I would. Um, like, I don't know. I'm sure it's fine, but I'm sure it's fine, but yeah, I just don't see the point. I'm already quite proficient in LaTeX, so I have a hard time believing that there would be any advantage to me. It probably wouldn't be hard for me to learn, but I just can't imagine, like, I never find myself being like, "Oh, I wish this was easier or faster," because I'm already good enough at it. And besides, everything is we already do, like, if you want to publish papers and stuff, it's all got to be in tech anyways. So, what am I looking at? I'm looking at a professor's profile to figure out which of these people on the paper I should contact to ask more about this area. I'm looking at postdocs in Europe. I've already applied to some postdocs in Europe. First glance, a perhaps not so conventional career trajectory. Okay, let's take a look. Wow, this is a cool visualization. BSc, PhD, then boom, visiting assistant professor. Wow, maybe huh. And then simultaneously holding these other things. Interesting. Well, I kind of want to email this person as well, just to ask her how the hell that all happened. Yeah. Yeah, the other thing I guess I the other thing I guess I need to the other thing I guess I need to consider also. I mean, this area does seem very cool, but then I'm like, yeah, how hireable is it? I guess clearly there's a lot of people publishing in this area, so maybe it is pretty hireable. I don't know. Yeah. I'm looking for hot Australian finite group theorists in Ohio at a university near you. I haven't applied to anywhere in Germany yet. No. Where have I applied? Um. So. Uh. Well, I actually have an offer, a sort of unofficial offer, somewhere. I feel weird talking about it because it's like not really. I didn't go through the usual application channels, so I don't know. Maybe I shouldn't be talking too much about it online until like it happens or if I take it. So I do actually have a sort of unofficial offer somewhere in Canada, and then I've applied to Australia, Sweden, Spain, the States. Yeah, yeah. So I've applied a number of places. What area am I talking about? What do you mean? What right now, or the areas I've applied to postdocs for? Professor Mathematics. Let's see. Yeah. Yeah, I don't know. I could probably reach out to any one of these people and ask. So I may just do that. I may just do that. Yeah. Wow. Ordered publication. Wow. 10 publications in 2025. Yeah, see, this is the other thing. This is also one of those fields where, like, I guess it's a lot more digestible. So you can pump out 10 papers a year, but then, like, is that the expectation? Do I need to be pumping out 10 papers a year? Like, that's crazy. Okay, maybe not. Maybe that was just a particularly productive year for him, I guess. Maybe just really hit his stride with a lot of stuff and collaborated with people. Yeah. Yeah, but this seems cool. Okay, I reach out to some of these people because this is interesting kind of stuff. Thanks. You need a tutorial for how to nepotism max. Well, what you need to do is network max. And you need to go to conferences, you need to talk to people, and you need to go to workshops and seminars, and you need to talk to people, and you need to hang out online and talk to people. Yeah, at the end of the day, you just got to talk to people. You got your PhD offer through official channels, and it was a nightmare. Yeah. Well, there you go. Right now, what area am I looking at on the web page? This is like representations of finite groups. Yeah. In that case, you need a tutorial for how to talk to people. Well, I can't help you with that. Yeah, I don't know. There's probably YouTube videos. There's probably YouTube videos how to talk to people. Yeah. Recently settled Brouwer height zero conjecture. Very cool. Very cool. Very cool. Let S9 be a symmetric group. Then G has two P blocks. Yeah, I don't know. Anyways, seems cool. That's my takeaway. You didn't know people still research representations of finite groups? Well, now you know. Macro aggressive. Yeah, we have this weekly meeting that we call micro local T because we meet with a differential equations person and try to understand micro local geometry, micro local analysis, blending our algebraic perspectives with her analytic perspective. And anyway, sometimes me and my friend jokingly call it. We refer to it as macro global coffee. I don't know why. It's just fun to take the opposites of words. Everyone loves a contravariant functor. Okay, on permutation characters of finite groups. I've been thinking about this for a silly little project of nothingness, so this could be useful for me as well. Yet I never ask for your awesome perspective. Wait, what? What was that in reference? What was I just saying? I have no short-term memory anymore because I've been watching too many YouTube shorts, so I can't even keep up in the conversation to understand Leo's jokes. It feels perfectly fine, Boris. It feels perfectly fine. Okay, so it looks like this is typical terminology in the field. Let G be a finite group, and M a maximal algebra perspective, analysis perspective, and Leo lectures awesome perspective. I see. I see. Well, if your perspective can help me compute vanishing cycles of perverse sheaves, then please lay your perspective on me. G is a finite group. M is a maximal subgroup. Okay. We call every irreducible constituent of... What? Is this, I guess, the induction of the trivial character? We call it a P character of G with respect to M? Why P? P for what? In this paper, we prove that all P characters of G are monomial. Oh, if all P characters of G are monomial, then G is solvable, which solves a question posed by Qian and Yang. Okay. Let's get a little bit deeper. How do you learn awesome mathematics? You've been trying to get into it. Well, first you have to study striking mathematics and very cool mathematics. Those are the prerequisite. Throughout this paper, G is a finite group. Recall that chi is monomial if it's induced from a linear character of a subgroup of G. And that G is an M group if all its irreducible characters are monomial. Monomial induced from M specifically, I'm guessing they meant to say. We know that M groups are solvable, and that every solvable group is contained in an M group. We know that M groups are solvable, and that every solvable group is contained in an M group. Okay. More interesting results on M groups can be found in 2. Let M be a maximal subgroup of G. Then G acts on the set of right cosets of M, and it induces a transitive permutation character. Let M be a maximal subgroup of G. Then G acts on the set of right cosets of M, induces transitive permutation character. Totally unrelated, but has anyone in chat learned Cohen's forcing proof? I've always wanted to learn about it for the lulz, but there's zero decent exposition. I do remember a friend of mine, I think for their logic class, they did a project on Cohen's forcing method. One of these days, I mean, I should not promise this. We're a ways away from it, but I've been thinking about making some videos on the Grothendieck topologies. I think today I might talk about gluing sheaves, just ordinary sheaves, but I don't know if this is the best way to do it, but later in this book, there is supposed to be a topos theoretic approach to forcing, I think. But I had there was a set theorist in my comment section once that was really hating on the way it's done in this book. But I don't know. Maybe that guy's just a hater. Where is it, though? Maybe I should look at the introduction. Maybe I should bring up the book on screen. How about that? Wouldn't that make sense? Let's see. Too many documents called sheaves in geometry and logic. Let us have a little look-see. Let us look inside the book. Let us have a little think about the contents and materials. 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 Yep. Boo, 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 boo. What are you guys talking about in chat? The talk you linked said the proof was lame. Is it true? Is it lame? The talk? Wait, who linked a talk? I linked a talk? Did someone link a talk? Why are we in top chat? Why didn't I turn on live chat? I probably missed some messages. Ooh, here you go, Boris. Exposition. Oh, that's what you read and didn't like very much. A hater in the comment section? Yeah, never happens. Never happens, Sawdust Creator. Yeah, try reading again. I'll lock in change in 4 years. There's a lot of things I've read when I was younger and then came back to later and understood better. A lot better. You could say I understood a lot better. Afterwards. Maybe I should make more videos where I have like annoying characters, where I play different characters. I play different characters having a discussion about a theorem. That could be a thing, you know? I don't know. Maybe I should try it. You know, there's these, lots of people are getting popular doing characters on YouTube Shorts. So maybe I could mix, you know, playing different characters and have like a Socratic dialogue about the proof of something. Maybe I'll just try that out. Have I seen any non-standard models of ZFC before? I mean, I've done like a little bit of reading on like intuitionistic ZF, IZF. Bro was a choir boy or something. Never been a choir boy, actually. Never been a choir boy. I'm not known for being a singer. That's one, certainly people have never known me for that. There are simpler ones than the ones you get from forcing. Probably. Richard Borchard has a series on ZFC axioms. Oh, okay. Well then if you're not talking to me, then I'll ban you from chat forever. Okay, let's see here. Chapter 6, we take up the idea, compare it with some developments in set theory. Our first example is a topos-theoretic presentation of Cohen's work on the independence of the continuum hypothesis. Yeah, so that's in chapter 6. Seems pretty cool, if you ask me. Seems pretty cool. What is this link you popping off in chat here? Oh, it's Richard Borchard's thing. Yeah. Mod gets perma-banned live. One of these days it'll happen. Yeah, so I don't know. We could go look at it. Now. We won't understand anything because we haven't built up the background yet. Yeah. Where's chapter 6? Let's go look. Is there a dependency graph for this book? No, it doesn't look like it. 267. Topoi and logic. The Borchard series is better than the forcing PDF. After presenting some special properties of topoi enjoyed by the category of sets, we turn in 2 to the famous proof of continuum hypothesis. So let's just skip there. Background is for suckers, and we ain't suckers. If you need to understand every word that you read, then you're weak. Cantor's diagonal argument shows that the real numbers are not denumerable. Now, if we write n for the set of natural numbers, the real numbers can be identified, at least as far as their cardinality is concerned, with subsets. Thus, the diagonal argument shows there's no bidirection, so we have this. Cantor's continuum hypothesis. Yeah. Cohen devised the method of forcing so as to violate this hypothesis. Cohen devised the method of forcing so as to violate the hypothesis. In a nutshell, his method is as follows. Starting with a suitable model S of set theory, take an S some set B larger than the power set. Yes. Then construct a new model, S prime of set theory, in which there is a monomorphism. Wait, can you do that? How can you do that? Okay. Well, I guess as part of the argument is that one can do such a thing. This is crazy. This seems crazy to me. That seems contradictory. How could that possibly... okay, yeah, it's whatever. Set theory and logic is weird. Is there a day that you're not doing puns, Leo? Ever? This will almost, see below, mean that this is true, holds for the corresponding cardinal numbers in S prime. Since this is true, one may replace the desired function g by its transpose. I gotta remind myself what the hell that even means. I guess this is the transpose. Thus, giving f really amounts to giving the graph of b times n of a many-valued function from b to n consisting of those pairs. In the given model of set theory, there is, according to the diagonal argument, no such function f. There are, however, finite approximations to f. Such finite approximations will then consist of a finite subset and a function one calls FPP, condition P. In other words, a condition consists of two disjoint lists of elements, blah, 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 blah. Okay, these conditions constitute a poset with partial order defined by this. Okay, in set theoretic treatment, such a poset is often called a notion of forcing. Okay, so we're constructing some kind of poset. Now, start with the topos sets of classical sets and consider this Cohen poset P equipped with the dense topology. The Cohen topos is by definition the corresponding category of double negation sheaves. Okay, so we gotta go studying that. Oh, Sand Magic, I didn't see your previous... I didn't answer your previous comment. Sorry about that. Do I know the most... forgot to answer the most controversial areas in math? I don't really think there's very many controversial areas in math. I mean, you know, there's the IUTT, right? Inter-universal Teichmüller theory. That's pretty controversial. But are there other areas that are controversial? I don't really think so. I mean, some people are haters about other areas of math, but yeah, I don't really think there's much that's considered controversial. Some people have feelings about the axiom of choice or whatever, but Yeah. Uh, Cohen being a wicked witch, concocting and devising evil potions. Yes, should have been Cohen for Halloween. By the way, watching Borchard's series will help you with at least one question on Math Jeopardy. Well, I don't think I'm going to watch the entire series just to help with one question. You're 8 years old. You came across and see me live, but don't know anything. Well, you know something. You know how to type in the English language. That's a thing. What I'm doing and talking about right now. Yeah, I mean, this is pretty crazy high level math stuff. This is pretty crazy high level math stuff right now. But hey, I don't know. Keep stay in school and study hard, and one day you'll be able to understand what the double negation category of sheaves means. So what's a topos? A category of sheaves, basically, in a very general sense. This channel may or may not discuss it eventually. As we saw at the end of the previous section, the Cohen topos is a Boolean topos, satisfying the axiom of choice. Boo, boo, boo. The purpose of this section and the next is to prove that in the Cohen topos, there exists an object together with monomorphisms in here. Okay. Where n is the natural numbers object. This is the subobject classifier. And such that there is no epimorphism here nor any epimorphism there. Okay. I see. Nice. Yeah, one day it would be great to understand this. One day it would be great. Does that mean we're on Shoot and Fudge watch? I don't know what you're talking about. What's the category of double negation sheaves? That's a good question. I don't know. Eventually, this channel may talk about it. But well, first one needs to know what the category of sheaves on a site are. This I kind of know, but I don't know what the double negation category is supposed to be. Stay tuned. Stay tuned for a very long time because it will be some time before we get there. But anywho, I think that's enough yapping from me for today. So, thank you all. For joining me. And QED.